In the last video, we took a look at the first example on page 591 and saw that if we took a definite integral with a variable as its upper bound, and then we took the derivative of that function, we kind of wound up with where we started off again. So let's take a look at the second problem and see if we've got the same thing going on there. All right, this time our function is cosine of t. So they want us to calculate big F of x, which is the definite integral from 1 to x of cosine t dt. So once again, pause the video, give this a shout. It's just now we're taking the antiderivative of a trig function. So make sure you know how to do that. So remember, with antiderivatives, you're thinking to yourself, what function has cosine as its derivative? And the answer to that is sine. So we're looking at sine t as our antiderivative, and we're evaluating that from 1 to x. And all that equals is sine of x minus sine of 1. So that's our big F of x. And now they want us to take the derivative of that. So what is the derivative of sine of x minus sine of 1? So the derivative of sine is cosine, like we said before. What is the derivative of sine 1? That might throw us for a little bit of a loop, but that is just the sine of 1 radian. All right, so that's just a real number. So I've got my calculator set to radians here. So that's just a real number. It's this real number, but that doesn't really matter to us. The only thing that's important is that this is a constant. So it goes away when we take the derivative of it. And so once again, the derivative of this definite integral function is pretty much right back where we started out with, except that this was a function in terms of t, and now we've got a function in terms of x. So two things, maybe that's not a coincidence. And what we're going to do in the next video is we're going to name the fundamental theorem of calculus in this second form, even though it's called the first fundamental theorem of calculus. And we will talk about the limitations of this rule and how to apply it.